Good morning, and welcome to Migrating to Modules. So this is one of several talks here this week. Modularity is a deep and complex topic. The module system is on the surface designed to be approachable, but there are lots of subtleties. So just to calibrate, how many people saw Alex Buckley's talk yesterday? Okay, good, maybe half. How many people saw my talk yesterday? Okay, more than half. Okay, that's a good foundation. But still, this again is like my talk yesterday is going to be almost entirely live coding. I might make some mistakes. If you see me make a mistake and you know how to fix it, just shout it out. Also, if you have a question of clarification, feel free to shout that out as I go. But I might defer an answer till later. So here we are again with a few days old build of JDK 10, not 9, 10, just because life on the bleeding edge is so much fun. What are we going to do here? So the theme here is migrating to modules. We're going to look at a little application, an application somewhat more sophisticated than the Hello World that I was playing with yesterday. Look at this little application. We're going to convert it into a module. Now, this application uses some popular libraries that have not yet been converted to modules. So we'll see how we can still modularize our application even though those libraries have not yet been modularized. And then we'll do the reverse thing. If you remember Alex's sandwich diagram from yesterday, we'll do the reverse thing. We'll go back to the application just being a regular old jar file. We'll pretend that we're the maintainers of the libraries that we used in the first part, and we'll modularize those, and we'll see how we can have modular libraries and a non-modular application. And then finally at the end we'll have just a beautiful module graph. Everything will be modules, the class path will be empty, and life will be good. So that's the general plan here. Okay, so to get started, let's look at the little problem we're going to solve. I have here a JSON file, data format of the century, of tweets. So a bunch of tweets off my timeline from Twitter a year or two ago. I guess you can read it if you really want to, but it's kind of difficult. So we're going to write a trivial little app to format these tweets in a nicer manner. Actually, we're not going to write it. I already did write it. So what have we got? Here's my source tree, a little application called TweetSome. It's got a main class and a tweet class. Let's take a look. TweetSome main. Okay, it's in a package. It uses lists. It uses the JSON data binding library. So it's going to deserialize that JSON using Jackson, do an object mapper thing. It's got a public static void method. It makes an object mapper, configures it, reads from the standard input stream, constructs some tweets, and then displays them nicely. And it uses this tweet class nearby, which is just a very simple Pojo object. We can look at that too. Here's the tweet class. It also uses a couple of Jackson annotations to identify the fields. It stores the time of the tweet in a SQL timestamp just for amusement, and it's pretty obvious. So it's got a text field, which is the text of the tweet. It's got the timestamp, and the annotations to tell Jackson, please convert this using the following format into a SQL timestamp. So that's all pretty straightforward. Let's just make sure that this all works. We'll just compile and package this as a normal little application. So let me compile this in the old-fashioned way. Classes. Let's see. I've got my lib directory here. Here are the Jackson jar files. It's actually a slightly old version of Jackson, but that's okay. It still works. Annotations. Core. Data bind. All right, I've got classes, pretty much what you would expect. I'll create a jar file. All right, so now I'm ready to go. Java class path. Oh, the class path is so tedious. I'm going to cheat and use class path wildcards. How many people know about class path wildcards? Obscure feature introduced in Java 6, but really handy for stuff like this. So class path wildcards, they're just going to put all of those jar files directly on the class path because that's the way the class path works. TweetSome.main, and let's read that JSON file. Boom. Nicely formatted tweets. Okay. Slightly, marginally more interesting than hello world. So we've got TweetSome. Let's convert that into a module. There's our source tree again. To make this into a module, we need a module declaration, and module declarations go in files called, by convention, module-info.java, and that's going to go in the root of the tree right here, right in the directory corresponding to the module name. So we pop up here, module info.java. And we'll use the recommended reverse DNS convention, same as for package names. And in fact, the one package in this module is the same as, it has the same name as the module itself. That's fine. So what are the two fundamental things about a module? What does it export and what does it require, right? So what does this module export? Nothing. Very good. It's an application. Doesn't need to export anything. A module is a set of packages designed for reuse. Footnote, or a set of packages that's an application. And it's designed for reuse, but not as something that you can require. So we don't need to export anything. What does it require? Well, we know that it's using those Jackson, it's using the Jackson API to deserialize the JSON into the Tweet Pojo instances. So we could write requires, if I can spell requires, but what? Because those Jackson, all we have are Jackson jar files. They're just jar files. They're actually jar files that are a couple of years old. They're not modules. What do we do here? Well, we could just give up and say, oh no, this module system stuff is too hard. But actually, there's another thing we could do is we could go and hack the Jackson jar files and force in our own module infos. But that's not really a good recipe for a maintainable system. Taking other people's jar files and editing them and making your own, that almost always leads to tears. So we won't do that. What we will do is we will use a feature of the module system called automatic modules. Alex mentioned these yesterday. Automatic modules are a way of treating a regular old jar file without changing it at all. Treating a regular old jar file, as long as it's reasonably clean and consistent, you can just treat that as a module. Instead of leaving it in a lib directory and putting it on the class path, you can put it on the module path at both compile time and runtime. The module system will see it there, and as long as the jar files you're using as automatic module don't have conflicting packages, there are no split packages amongst them, then the module system will treat them as modules. It will, in effect, synthesize module declarations for them at compile time and runtime. It will make sure that they essentially all require each other by default, because that's the only thing that makes sense. And this allows you to migrate your own code before your dependencies have migrated. So, what will these things? The question here is, well, you've got a jar file. It itself is not a module. You put it on the module path. What is its name going to be? And that's what I need to know to type something here. If I look in the lib directory, well, all I see are artifact ID / dash version number.jar. So the answer is, and this is a heuristic, but it turns out it works fairly well, is the name of an automatic module is taken from the name of the jar file. Take the name of the jar file, lop off the version part if there is one, convert remaining punctuation to dots. You drop the jar suffix on the end, and a couple of other little heuristic rules. They're in the spec. And so, in effect, what we have are three modules called Jackson.annotations and Jackson.databind and Jackson.core. So I can go back in here and actually type this. Okay, so I'm going to use these existing jar files as automatic modules. There's another way to figure out what modules an existing jar file application might need, and that's with the JadeEPS tool. How many people know about JadeEPS? We actually shipped an early version of it in JDK 8, so you could use it earlier. There's a much improved version of it in 9. You can run JadeEPS with the -s option, and it will tell you, it will do basically it does static analysis on the bytecodes and figures out what modules might be needed. I should tell it here about the automatic modules, so I'll give JadeEPS a module path. Oh, sorry, no, I need to do this. It's class path still. Quote. There we go. Right, so we see that TweetSome jar file, it needs the three Jackson annotations jar files. It needs Java base, because every module needs Java base, whether it wants to or not. Oh, and it needs Java SQL. Remember, I used that Java SQL timestamp class for the timestamp. So I'm also going to need to write requires Java SQL in my module declaration. All right. Now I should be good to go. I'm not missing anything. Oh, little side note. Another cool thing JadeEPS can do is check for uses of JDK internal APIs. And since this doesn't use any JDK internal APIs, but if it did, JadeEPS would list what they are, and in many cases it will offer a suggestion of what standard API to use to replace it, because there are many uses of internal APIs out in the world where standard APIs have been available for a decade or more. Anyway, end of side note. Okay, so we've got our module declaration. Let's compile everything here. I'll just remove that. So Java C. So Java C has gotten fairly sophisticated. It understands the structure of a modular source tree. It can generate an exploded classes directory that has an additional level of directories for modules, and that's what this mods directory is going to be. It also understands module source paths. So Java C-D mods, we need to tell it where those automatic modules are. They're here, module source path. Source, and we just tell it what module we want it to compile, and it will go into the modules. It will go into the source directory, find the directory named org.tweetsome, and compile everything under that. We don't have to do the tedious old thing of, oh yeah, go find every .java file, because that's just tedious. All right, and there's my modular output directory. I've got module info.class, the compiled form of the module declaration. I can run Java P on it, like with any other class file, and it will essentially disassemble it and tell me what's inside. I can now create a jar file in the usual manner. I'll tell it what the main class is to save some typing later on. Whoop. Double dash, please. Okay. There, we've got that. And I can See what's inside. There's my modular jar file with the module info inside it. So not only has Java SE gotten sophisticated, but the Java launcher has gotten sophisticated. I can run this now. Well, actually, first let's take a look. There's some more options on the Java launcher that can let you inspect what's inside a module that it can find on the module path. So let's describe that module. And here's output in a easily greppable form if that's what you need to do. Here's the org TweetSome module. Here's what it requires. Here's what it contains. And of course, it doesn't export anything. Okay, so we should now be ready to run this, right? We've got our org TweetSome jar file. We've got our old Jackson jar files. We're going to use those as automatic modules. They're there in the lib directory. So I should be able to just run the Java launcher, tell it to run the TweetSome module, and give it the tweets.json file as input, right? Is it going to work? Loaded question, I know. All right. No, it's not. All right, what happened? What happened was, let's see, exception in thread main, Java lang reflect inaccessible object exception, unable to make org TweetSome tweet accessible, does not open org TweetSome to module jackson.databind. What is going on here? Well, remember, we concluded that the TweetSome module doesn't need to export anything because, well, it's not providing an API to anything. But the Jackson data binding library it's one of these reflective frameworks that uses reflection to go manipulate POJOs, instantiate them, and fill in their fields using the reflection API. But since we have strong encapsulation, one of the main features of the module system, that strong encapsulation is getting in the way. And the Jackson data bind library, its attempt to use reflection to set up instances of the tweet class is just not working. So what can we do? Well, all right, let's try exporting, even though it's not. It's not an application. This isn't an API, but we'll export it, and that should make it accessible to the Jackson data binding library. So let's compile this again. Rejar it up. And try to run it. No, try to run it. That still didn't work. Why didn't it work? Well, it didn't work because I didn't read the error message closely enough. We've tried to put lots of hints and advice in these error messages. So when you export a package, then at compile time and runtime, the public members of that package are available for use. The Jackson data binding library is trying to use reflection to get at non-public members of the public tweet class. And if you just export an API, you can't do that. And that's a good thing because that means when you have a module that exports an API, you can defend the module's internals against abuse by code outside of the module, whether that abuse is accidental or malevolent. So, as the message suggests here, there is another way to do this. There's an alternative to exports called opens. It's a little bit like exports, but it's actually fairly different. You can go back here and say that org TweetSome opens the org TweetSome package. What that means is the public types in the org TweetSome package are not accessible at compile time. So there's no API here. You can't compile against it. They are accessible at runtime for use by reflective frameworks. And not only are they accessible at runtime, but if a reflective framework wants to really get down and dirty and access private fields, it can use Java lang reflect accessible object set accessible, the magic set accessible method, to dig into those as it always could in the past. So basically, if you're writing a module that you know is going to be manipulated by some reflective framework, you need to open the packages that contain the classes that the framework will manipulate. If you have a module with a lot of such package, you can actually open every package in the module by writing open at the top. But we'll just stick with this for now. All right. Let's recompile that. Let's rejar it. And finally, we should be able to run it. There we go. Okay, so here we have a modular application, an application in a single module. It's using the Jackson jar files as automatic modules, and the system is working as intended. There's nothing left on the class path right now. Okay, we can take it. Let's make a little JRE to take a bit of a closer look here, and I'll just use a make rule I had left around. So here's a little JRE. It only has the modules that we need, and I can now run using this. And that should work. Okay, good. I can also use there are various other diagnostic options. For example, show module resolution will show you the activity of the module system's resolution algorithm as it figures out what it needs to do. So we start at the top, the root module, the module I gave. The module I identified with the -m option. I told the launcher, please run starting with this module. So that's the root module. It saw that org TweetSome requires Java SQL and then Jackson data bind and Jackson annotations and Jackson core. It tells you helpfully where those jar files are in case you need to find them. It also found Java SQL requires XML and SQL requires logging and so forth. And there's some other stuff going on here. So it's a very useful tool to diagnose exactly what's going on at system startup, so you can figure out maybe if some modules got loaded and you don't know why, you can read this output and figure out what's happening. All right, so that's automatic modules. Automatic modules they're good for modularizing applications and code that you own and maintained. I strongly recommend that you do not make use of automatic modules in a library that you publish. It would be a bad idea if you maintain a library and you publish on Maven Central, and it says requires Jackson.annotations. That's not the best plan. The reason that's not the best plan is, well, the maintainers of Jackson, they will actually hopefully decide to use proper reverse DNS module names, and it'll be up to them to figure out what those are. So please don't publish a jar file that presumes to give someone else's module a permanent name. There actually is a way as a little baby step towards modularization. If you maintain a library, you don't want to do the full modularization just yet, but you want to stake a claim for what you think the module name is going to be. We actually defined a new jar file manifest entry called automatic-module-name. You can put that in your manifest, and then if your jar file is used as an automatic module, that is what the name will be, rather than a name synthesized for the jar file. So if you want to claim a name for a published library module today, you can do that with a very simple change, and then worry about writing your module info later on. Okay, so let's rewind here. I'm going to clean things up, and I'm going to push a patch here. And now we're in a slightly different environment. What we're going to do now is modularize the Jackson source code. Maybe I'm putting on a hat, pretending I'm an honorary maintainer of Jackson, and we'll look at the source code and make some module infos and convert those into proper modules. And we'll do this while treating org TweetSome again just as a plain old jar file. So let me remove that. I'll recompile that. I'm going to use this little JJ command to save some time. Okay, no module info. It's just a plain old jar file. Okay, so let's modularize Jackson. We've got the Jackson sources here. I can run JadeEPS on the library forms, right, to see what they might need, and that works well enough for figuring out requires, but it doesn't tell me what those jar files as converted to modules need to export. Now, if I actually were a Jackson maintainer, I might just know, but so pretend I'm a newbie Jackson maintainer. I just came onto the team, and here I am trying to figure things out. So another thing I could do is I could look at the directory structure of each one. And that gives me some information about the packages. But actually, another thing that JadeEPS can do, JadeEPS is sort of the Swiss Army knife of tools for analyzing class files with respect to modularity. I can ask JadeEPS to generate a module info.java file for me. So JadeEPS generate module info. It will put that into the source tree, and I want it to generate a module info for this jar file right there, and it goes off and does that. Now, if you use this option of JadeEPS, it's important to treat its output as a draft, right? JadeEPS can only do so much. There are many things that it is incapable of comprehending, being a fairly simple static analysis tool. So here's what JadeEPS produced. It found every package and just decided, okay, yeah, we're gonna export every package. Don't know any better. And it also figured out something about a service that the Jackson core module provides. Now, services, what? Huh? Services? What's that all about? Another big feature of the module system is it actually understands services. If you remember the service loader API introduced way back in Java 6, that's been enhanced and integrated with the module system. So not only can a module require another module and export packages for use by modules that require it, but a module can provide services, and it can use services that may be provided by other modules. Services are a very powerful indirect mechanism, and if you ever find yourself in a situation where you think you might need to have two modules and each one depending on the other, the answer to that problem is probably for one of them to be providing a service and the other one to be using that other module as a service. But end of digression. I don't have time to get into services in detail today. But anyway, so we see that the Jackson core module, it provides the service, and JadeEPS figured that out because Jackson core actually has this meta-inf services entry for JSON factory. All right, enough about that. Okay, so I can now compile the modularized Jackson core. Takes a little longer because there's some real code in there. And I'm putting these new ones in a different directory called mlib. Okay, so that's done. I need to do an equivalent thing for annotations and data bind. So let me do that. I'll just do all of these at once. Okay, it tells me it's written those three module infos. Let me check them out. Data bind, module info.java. Here it's exporting everything. Remember, this is a draft. Should it export every one of these? Well, probably not. In fact, packages that contain the token impl, those are probably internal, so let's not export those. And there might be other things that shouldn't be exported, but won't go into that here. Okay, Jackson annotations. That's very simple. It only contains one package, and they're just annotations. So, of course, we want to export those. All right. Okay, let's compile these. Ooh, some input files, user overrided deprecated API. Oh, we just have so many things to fix, but we're not going to fix that one today. Okay, so now we've got our modularized Jackson modules. We've got our old tweetsome.jar file. We should now be able to run this. So, Java module path, mlib, class path, lib org tweetsome.jar, and we should now just be able to say org tweetsome main tweets.json. Unable to initialize main class org tweetsome main. What happened here? Well, what's going on now is I've got some code on the class path, and I've got some modules on the module path, but the launcher and the compiler would have the same problem. There's no way for the module system to tell, well, what modules might the code on the class path need. So I actually have to tell the module system myself, and I do that with another option called add modules. So I do this, and now it works. Okay, so now we've got kind of the inverse of part one. The TweetSome application is just in a jar file sitting on the class path. The Jackson libraries, the Jackson jar files have been properly modularized with explicit module declarations, and they're sitting on the module path. So now to finish up, let's just go back to the TweetSome source code. We'll put that module info.java back in. We'll recompile TweetSome. And now we've got in mlib 4 modules, explicit modules, and we can run everything right there. We don't need the class path, don't need to say add modules. Now everything is in a module. Oops, except I forgot to do that. Oh well. Tell it where the main class is. There we go. Everything's a module now. We have a nice clean modular system. We can also do things like show module resolution as we did before. And here we see that the Jackson modules are being loaded as they were before, but previously in this output, when they were automatic modules, each one of these lines ended with the adjective automatic, so you could tell they were automatic. Now they're not automatic; they're actually explicit. Everything's nice and clean. Okay, so I hope I've been able to show you that migrating to modules is possible. You can do it from the top down. That was the first part, using automatic modules. You can do it from the bottom up if you maintain libraries and all of the dependencies of those libraries have already been modularized. And eventually, everybody hopefully can work towards having, the entire world be modularized, but that will, of course, take some time. This is, at a higher level, kind of a migration trick that we borrowed from generics. If you remember generics, when we introduced them to Java in Java 5, one of the aspects of that design that to this very day remains a bit controversial is the fact that they use erasure. Some people find that dissatisfying and would prefer fully reified types, fully reified generic types. But the reason we went with erasure is that it allows gradual migration of code relative to other code, whether the other code uses generics or not. You can generify your own code without waiting for a library that you used to be generified, and likewise you can generify a library without requiring all users of that library to generify their own code. This is the same kind of migration compatibility, forwards and backwards, trick that we're doing here. You don't need to wait for all of your dependencies to be modularized before you play with modules yourself. And likewise, if you're going to modularize your own library, you're not thereby forcing all of your users to modularize before they can use the new version of your library. All right, that's it for now. We've got about 12, 14 minutes for questions. Any questions? Oh wait, I need to show you one more thing. Whoops, sorry. Don't believe a word I said. And here's where to get more information. The JEPs and the Jigsaw project page, they're linked to from the Jigsaw project page, authoritative source, fairly dry, but intended to be complete references. If you want even more information, I would recommend the recently published book by Sandra Mack and Paul Backer, Java 9 Modularity from O'Reilly. Okay, questions? We have a hand mic? Much easier than me repeating things. There are some microphones on the mezzanine. Sorry, he's closer, he wins. I'll get you next. Morris.
I'm sure I missed this, but you cautioned us against using automatic module names for a library that you are going to put into Maven Central that you yourself are modularizing. So if you're in the middle of the stack, and the things that you're dependent on have not been modularized, but you're a library that you want to export to other people, what is the way of getting around the problem that you told us about that?
Wait. If you're in the middle of the stack, it's best for you to wait to publish a modularized version of your thing until all of its dependencies have been modularized. There's just no way about that. No way to get around that.
Potentially that's a problem, right?
Happy to hear a solution if you've got one. we thought about it long and hard, and just don't see a solution for that. I mean, if you're in a situation where you maintain those libraries for internal use, within a constrained organization such that you can control it, then sure, go ahead and do that, publish them internally. But please don't publish them to central, because eventually the maintainers of those libraries will choose their own module names, and they're likely to be different, and then everything's going to break all over again. So it's a risk you can take, but you'd probably would be doing a disservice to your users.
So really, what you're going to be urging every library maintainer to put in that automatic module name into the manifest straight away.
Exactly. That's the first thing to do. If you maintain a library, you don't have time to think deeply about it and modularize it today, but you know what you want its module name to be, then just add that manifest entry. Only takes a couple lines in pom.xml or whatever, and claim, stake your claim. Once you do that, it's safe for others to use your library with that automatic module name. So yeah, that's the recommended path. Okay, there was someone here.
Thank you. You explained about reflection, opening it up for other libraries, like the Jackson data bind. But how does that work if you want to use reflection on other automatic modules. Can you use that as well?
Yeah, automatic modules implicitly open everything.
Okay.
So yeah, I mean, automatic modules are they kind of, well, I could say something rude, but I won't. Other questions? Well, you were right next to a mic, but here, you can use this one if you want.
Can you use wildcards in the module info.java file?
No.
Okay.
And then that's an intentional design decision because we think that exporting something is an act you should think very intentionally about. If you could say exports star, then something's likely to go wrong down the road. Other questions?
Yeah, how do you deal with it if someone makes a module not open and I want to actually use entities in that module by Jackson reflection? So it's not an open module, but I do want to use those entities for reflection access.
So that's a good question. There are various workarounds. In the API you can actually delegate the reflective power from one module to another. Sometimes that works. As a last resort on the command line, there are options, and these are all explained in JEP 261. There are command line options whereby you can force any arbitrary module to export a specific package or open a specific package. So that's kind of the hammer that you use if you're desperate.
If I saw it correctly, you used a smaller JRE. How did you create it? Yesterday you showed how to link some modules to the application, but how to create an isolated JRE with only a subset of modules.
So I made that JRE with the same kind of JLink command that I used yesterday, using the Java linker, and I just specified to it that I wanted a set of 4 JDK modules in the resulting image, and without any application modules. So yeah, it's just another instance of the JLink command. Any other questions? Not sure where we are on time.
When you use the opens statement, can you open up to a specific module?
Good question. Yes, you can open a package to a specific module or a set of specific named modules. You can also export a package to a specific module or set of named modules, so you can constrain the accessibility of what it is that you're making available. And we actually use that a lot in the JDK modules themselves, because there's still lots of interconnections, since it started off we started off with this huge complex monolithic system with lots of bizarre dependencies, some of which we just couldn't get rid of. So if you go look at the module infos in the JDK source code, you'll see that the Java base module, for example, it exports sun.internal or jdk.internal blah 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 to a specific probably a dozen other JDK modules, and we have a hashing mechanism in module artifacts that enforces restrictions so that you can't spoof the system. You can't make your own module named java.sql and thereby get magic access to the internals of java.base. We did think about that problem. All right, any other questions? Anybody closer? I'm getting lazy. No, you're not that much closer. No. He's, where were you? Here? Let's try to go in order.
Thanks. You explained us the backwards compatibility along analog to the generic system.
Mm-hmm.
I can imagine that many of the backwards compatibility problems with modules will be using previous JDKs for all the bad reasons. So how would you compile module-compiled jars against older JDKs?
Right. So one of the beauties of modular jar files is they're just jar files. So if you maintain a library that you want to make into a module for use on 9 or later, but you still want it to work on earlier versions of Java, say, I don't know, JDK 6, you can do that. You just need to make sure that you compile the module info.java with JDK 9 or later, and compile all the rest of your code, dash release, whatever the earliest release it is you want to support. And then the resulting jar file, you can put in the module path in 9 or later. You can put on the class path for an earlier release, and the module info class file will just be ignored. There's no reason, the VM, the compiler will never look at it because they have no reason to. They wouldn't understand it if they did. So that's the solution. And I think there's some, I think on one of the Maven web pages, there's actually an example of how to configure your POM so you can compile the module info with 9 and all the rest of your content with an earlier release and get one of these hybrid modular jar files. Okay, there was someone else here. Okay, you're next.
There is a question on the board about versioning and that the modules are useless if you don't have versions.
They would be so modules would be more useless if they did have versions, actually. So this is a frequently asked question. There are several answers to it, some philosophical, some practical. The philosophical one is that we don't put versions on classes. We don't put versions on packages. We don't put versions on fields or methods. Modules are a linguistic concept in the programming language. We shouldn't put versions on those either. It's fine and useful to put versions on the artifacts that define these things, but putting versions on the actual actual modules themselves is not helpful. I thought I turned that off. Okay. A more practical reason why the module system doesn't do versions itself is that whatever it did would almost certainly conflict with what Maven does, what Gradle does, what Ivy does, what all these other existing version resolution systems do, and they're all different. So it would be very unsatisfying. We would create a module system that few people would use if we baked it into the system and it conflicted with all of the existing build tools. So we didn't do it. And it was kind of a surprising conclusion when we came to this, because a very early prototype of Jigsaw did have version constraints in it. But when we realized, these other tools that everybody's going to keep using already solve the problem, maybe we just don't need to solve it. And it's worked out fairly well. Okay, I think we've got just a couple minutes left.
Does the packager for Java client or FX applications uses or supports modules too and the JLink tool?
Yes, the Java packager in JDK 9 understands modules. JavaFX, we modularized JavaFX, so it's a set of, I don't know, like 5 or 6 modules as well. So yeah, you can make a modular FX application and JLink it up, and you're off to the races. Any other questions?
Thanks. What would happen if I want to use 2 libraries which export modules with the same name?
If you have 2 libraries that export packages with the same name?
Yeah. Module names.
Wait, you have 2 libraries and each defines a module and the module has the same name? Yeah. No, you need to pick one.
Okay, but how? How do I pick?
You pick one by configuring your build system to only have one of them in your module path. Or at least only one in each directory of the module path, and whichever one is first wins. Right? There's no heuristic clever enough to figure out which one of those 2 things you actually need. Now let me go check the time quick. 1 minute left. Last question. Anybody? Can a module extend another one? No. There's no inheritance amongst modules. That would be complicated. It's 30 seconds. Use the time wisely.
How does it fit with OSGI?
How does it fit with OSGI? It does not interfere with OSGI. OSGI works great on top of JDK 9 without change. And with that, we're out of time. Thank you very much. much.